everyone, I'm Iris Yazıcı and today I'm going to perform my Physics 101 project. The purpose of my experiment is to calculate the drag coefficient between these cupcake cups and the air. To calculate the terminal velocities of these cups from as far as I can, and I will assume that they reach terminal velocity at a height of 1 meter, and I will measure time until they reach the ground from when they are 1 meter above. I will do the same experiment for 6 times with a varying number of cupcake cups. The mass of one cupcake cup is 0.27 grams if I measure it with this value. And then I will plot the terminal velocity versus mass graph and terminal velocity squared versus mass graph to see which one is the appropriate model for this situation. Now you can see me perform the experiment 6 times with 1 to 6 cupcake cups. I calculated the time intervals for the cups to reach the ground from 1 meter height. I measured the times up to 0.01 second precision by looking at these video recordings. This is the data I obtained, which I'll now use to plot 2 graphs. As mass increases, you can see that terminal velocity also increases, but we are going to try and see which of the 2 graphs is linear. To interpret the graphs, we need some theory. Force of drag is proportional to either velocity or velocity squared. We have to choose the appropriate model for this situation. Force of drag can be expressed as 1/2 the coefficient of drag times the cross-sectional area of the falling object times the density of air times velocity to the n power, where n equals either 1 or 2. And we know that at terminal velocity, acceleration, thus the net force, is 0. So we can say that the gravity on the falling object, mg, is equal to the force of drag. So from this equation we get, if slope is constant, we have the right n value and the right model. Graph 2 in this case, where n equals 2, is a slightly better model. The radius of a cupcake cup is 8.5 centimeters. Since we now know every value in this equation except CD, it can be calculated. So coefficient of drag is found as 0.21236. The errors in the experiment come from the measurement of time and the radius of the cups. Another important error might come from the assumption that the cups reach terminal velocity at 1 meter above the ground. Anyway, 0.2 is a reasonable result for the drag coefficient between the cups and the air.